All right, so let's take a look at heat transfer. I drew a graph here. Along the x-axis is time. We don't need units. Along the y-axis is temperature. We're going to do degrees Celsius, okay? And what we're going to do is we're going to start off with solid ice, a solid block of ice at negative 10 degrees Celsius in a pot on the stove. We just came out of the freezer, so it's negative 10 degrees Celsius. It will stay, that ice will stay as a solid until we hit 0 degrees Celsius, which is its melting point, at which point the ice will start to melt. So we're going to have a combination of solid ice and liquid water. And then as soon as we rise above 0 degrees Celsius, we're just going to have liquid water in that pot. And now we're going to turn on the stove, and the temperature is going to rise. It's going to rise. We still have just liquid water. Once we hit it at 100 degrees Celsius, now that liquid water is going to start to turn into a gas. It's going to boil and evaporate. So now for a little while in that pot, we've got a combination of both liquid water and gaseous vapor, and that vapor is escaping. And then we hit a little bit above 100 degrees Celsius, and now all we have is gaseous vapor, water vapor. You've boiled the pot completely empty. Now, in order to perform this phase change, to go from a liquid water to gaseous water, that's boiling. In order to do that, we need to evaporate. In order to evaporate, we need to add heat from the stove. So, how does this apply to humans? Well, what we can do is, if you take an alcohol prep and you rub it on the back of your hand, or actually on your anterior antebrachial region, and you let go, you'll see that the alcohol prep will cool off the skin. You'll actually feel cool and will evaporate very quickly. That's because it is taking the heat from your body and evaporating the alcohol. Well, if you take heat away from the body, that means that your body temperature is going to drop. Okay? So that brings us to the 4 methods of heat loss or heat transfer. So evaporation. It's not good enough for you to just sweat when you're hot. Just sweating does not cool you off. That sweat needs to evaporate, because remember, that sweat needs to take heat from your body and turn the liquid sweat into gaseous vapor, and in doing so, it's going to lower your body temperature. Okay, we're also going to lose heat by radiation, which means that anything uncovered is going to lose heat. You can use an infrared, a thermal imaging camera, or an infrared camera to see where you have heat loss. So, for example, this is why I need a lid on my coffee mug so I don't lose heat by radiation. Conduction. Let's say you're watching a football game and the bleachers are really, really cold. Well, it would be a good idea for you to sit on a pillow or a cushion or something like that to insulate you. Conduction is when you have surface to surface touching and losing heat. Remember, heat always goes from high to low. It flows from high to low, just like diffusion, just like osmosis. Heat goes from high to low. It doesn't go from low to high. Okay, and then lastly, we have convection. Some of you may be familiar with convection ovens. They circulate the warm air throughout the oven to cook more evenly. Well, convection in heat loss or heat transfer can be witnessed by wind or by water. So you know it's cold out when it's a really windy day. You can also lose heat as the water, if you stand in a stream, the water is passing by you and pulling heat away from your body. So convection is either using wind or fluid to draw heat away from the body. So a really, really good example is newborns. When a baby is born, first thing that needs to be done is suction the airway, so get the airway open, and dry off the kid as quickly as possible. Get all that wet stuff off the baby, all the amniotic fluid, because we don't want the baby to lose heat by evaporation. We can put the baby right on mom's chest and do skin to skin. This way we're not losing heat. We're actually warming the baby up. We don't want to have any fans or any kind of air conditioning on. I mean, for mom to make her more comfortable, of course, but for the baby, don't put the baby in front of a fan. And lastly, wrap the baby in a blanket and put a hat on the baby, a little cap. Babies' heads tend to be about 18% of their body surface area compared to an adult's head, which is about 9% of the body surface area. So babies lose a lot of heat by radiation through their heads. So put a cap on them. Okay? Now, what does this have to do with heat transfer other than with babies? Well, it has to do with, remember when we did body temperature regulation? The effectors that kick in when your body temperature is too high is you're going to sweat. So not only do you need to sweat, but that sweat needs to evaporate. If the sweat is just running off your body and dripping, like if you work in a humid environment and the sweat's just dripping off you, it's not cooling you off. It needs to evaporate off you. If it doesn't evaporate and you're losing a lot of sweat, you're getting dehydrated. And also, we're going to shunt blood to the skin. We're going to vasodilate. So the blood vessels that go to your skin are going to go from being normal size to dilated. And the reason we do that is to bring a lot more blood volume to your skin so we can lose heat by radiation, conduction, and convection. So this is why it feels really, really good to take your hat off so that way you can lose heat by radiation when it's warm out, to sit on a cold surface like a cold stone wall, for example, or cold bleachers if you're not in the sun. And this is why we fan ourselves at graduation practice with the programs, because it feels good to lose heat by convection. Okay?